Hey everyone, welcome back to my channel. So if you are studying power electronics or electrical engineering, you must hear about this term, DC chopper. And today I am going to explain it fully in simple way that actually makes sense. In this video, we will cover what actually is DC chopper, how it works, what are the types, a simple formula you need to know, and where is actually used in real lives. So let's get into it. So first, what is DC chopper? It's very simple. A DC chopper is an electronic circuit that converts a fixed DC voltage into a variable voltage. Think of it like switch that turn on and turn off very rapidly. Imagine you have 100 volt DC battery, but you want only 15 volt for a motor. What do? You can't just use a resistor that wastes energy as heat. Instead, you use DC chopper. It switches the voltage on and off so fast that the average output become 15 volt. And because it's switching, no wasting energy. The efficiency is very high, around 90 to 99%. This switching is done by a power semiconductor device like MOSFET, IGBTs, or thyristor. These act as our fast switch. Now the important parts, the formula, don't worry, it's very simple. So the main idea is the switch goes on and off very fast, right? Now things about this, I have 100 volt battery but my motor need only 15 volts. So what if I make the switch on for exactly half the time and off for other half time? It means now I have 15 volt. Simple logic. This ratio of how long the switch stays on, we call it duty cycle. Write in as a D. Now there is two way to find D. First way, direct from voltage. I want 50 volt from 100 volt, so D equals B out divided by B source. That is 15 divided by 100t. It's 0.5, meaning switch stays on for exactly half the time. Second way, from timing. Now in real circuit, engineers look at the timing signal directly. So if T on is 2.5 millisecond and T off is also 2.5 millisecond, total T is 5 millisecond. D equals T on divided by T, that is 2.5 divided by 5, again 0.5, same answer. Now finally, output voltage formula, B out equals D multiplied by B source, so 0.5 times 100, we get exactly 15 volts. So remember, bigger duty cycle mean more voltage, smaller duty cycle mean less voltage. You are just controlling how long the switch stays on. That is the whole secret of DC chopper. And these techniques of controlling duty cycle is called PWM, pulse width modulation. Now let's talk about types. There are mainly two basic types of chopper, step down and step up. Step down chopper, also called bulk converter, gives output voltage less than or equal to input voltage. This is the most common type. Your mobile charger use this concept. Step up chopper, also called a boost converter, gives output voltage greater than input. This is sound strange, right? How can you get more voltage than what you put in inward by storing energy in an inductor and then releasing it? This duty cycle formula we just learned. I actually built this exact DC chopper circuit on my breadboard, and look, this motor is running at 12 volts, controlled completely from my Arduino and Python code. Same formula, real circuit, real result. Full project video coming next week. Now my favorite part, where it's actually used in real life. First, electric vehicles for speed control. Second, DC motor speed controls in industries. Third, solar power system. The MPPT control is in a solar panel system. It's basically a DC to DC converter using chopper principles. Number 4, battery charging circuit and power supply inside laptop and phones. So yes, you are surrounded by chopper every single day. Okay, let's quick revise. DC chopper converts fixed DC to variable DC using a fast switching device. Output voltage is controlled by duty cycle. Step down give less voltage, step up give more voltage. They are used in EV, solar, motor and your own phone charger. If this video helped you, please hit the like button, and it really helps this channel grow. Subscribe if you are new and drop a comment if you have any doubt. I reply to every comment. In next video, I'll show you how I actually build this DC chopper and control it from Python code on my laptop. So subscribe and stay tuned. See you in the next one.